In this video, we see how to use the method of the maximum likelihood in the case of an exponential distribution. First of all, we write the density of the exponential distribution, that will be lambda times the exponential to the power of lambda times x. Now we compute the likelihood, that is a function of lambda conditional on x, that is the product of the density for each observation, that will be lambda times exponential of to the power of minus lambda xi, that is equal to lambda to the power of n times the exponential to the power of minus lambda times the sum of xi. Now we compute the log likelihood, that will be equal to n, that multiplies the logarithm of lambda minus lambda times the sum of xi. Actually, we shall write the natural logarithm even here. So we take the first partial derivative of the log likelihood with respect to lambda. That will be equal to n divided by lambda minus the sum of xi. Now we have to impose this to 0, because in this way we are finding the lambda that maximizes the log likelihood. Now we rearrange the terms in this way, and this implies that lambda of the maximum likelihood estimation will be equal to n divided by the sum of xi, that is the inverse of the sample mean. And we are concluded. Then we have to verify whether the concavity, in order that we are achieving a global maximum. So we are taking the second partial derivative with respect to lambda, that will be equal to minus n over lambda squared, that is less than 0. So the likelihood function is concave on all the domain, so we are sure that is maximized at lambda of the maximum likelihood.